we're good. So there's the stone. I'm going to bring it down into position. That's pretty good, actually. I can bring it down a little further. I usually don't want to come closer than 7/10 of a millimeter to the bore, the finger. Something like that is fine. And what are your side stones, Teddy?
They're oval.
Okay. Do we have those in the file?
Yes.
Those would have been on the storage that said oval.
Yeah.
I have cakes here, but I don't have stones. What are the size of the ovals?
I think
I have a library, so whatever size they are, I have.
I think they're like 10 millimeters.
Okay, so they're going to be 10 by 8s. Not cabochon. That's actually pretty big. You probably don't want to go that large. Let's see what an 8 by 6 looks like. It has a setting with it. We don't want the setting. That's not bad. Let's take a look at a 9 by 7. By the way, it's very deep because it's for color. Most of my library is colored, so. Nine by 7 right here. Yeah, that's nice. I'm going to see if I have it in diamond. Nope. Well, yes, right here. Nope, I don't. So, all right. Is that okay for a size for you?
Yes.
All right. I'm going to change the proportions on it because they're wrong. This will only take me a second. 9 by 7 calculator.
I found the stone.
But I'll have to scale it up anyway, so I may as well.
They're 5 millimeters.
They're 5s?
Yeah.
Okay. That's very small for your stone. That would be an oval 5 by 3. That's quite tiny for your center stone. I would go bigger. Yeah. 7 by 5 was nice, actually.
Yeah, I agree.
7 by 5 was a nice size. So we'll stick with that. I just need my calculator. So 5 millimeters times 0.431, 2 millimeters, 2.2. So that's how deep that stone should be. That's looking a lot more normal. The crown on that, did I leave my calculator up? I did. The crown on that would be, what size is the stone again? 7 by 9?
Yeah.
So it'd be 7 times 0.162, 1.15, close enough. So the top of the stone should come to here. So it's a little too short now. And once again, same thing. Non-uniform scale. That seems tall to me. Hang on a minute. Quit fighting me. Come on. Analyze distance. Oh, it's 5 by 7. Yeah, it's a 5 by 7. Okay. That was why I have the wrong dimension there. So, 5.82. This is probably going to be just about right anyway. Still a little squat. There we go. And we're going to want a girdle line, so while I've got this here, I will steal a girdle line. Join this together. There, that's your stone. Don't need this curve anymore, don't need that curve anymore. Group that together. Cut it so I don't have to look at it. Paste it back in. Move it up into position. Something like that. Bring it over. Snuggle it up to the girdle. I do this first, Teddy, because I know I can't do that. That's what I have to avoid doing. And then I bring it down. And looking at your shoulders of your ring, you might want to come down a little bit more, but not much. And then rotate. So it follows the ring bore. Could be something like that.
Yeah. That was like I was going for.
Okay. I might bring them even further down. Because it looks pretty high up. And rotate a little bit more. Just so it has a little tighter. And that's what you had done. Your angle's actually a little tighter. This is pretty much the angle that you have here. But I'll lose these now. We don't need them. That works pretty well. Okay, I do the same kind of thing over and over again. I just do it slightly different each time because I get bored, primarily. Just because every time I do it, it seems different to me. I'm going to do a section across the top of your 3 stones. If any of these commands confuse you, Teddy, when you go home and look at this, you want to go into Rhino and hit F1 help and see what it is that's not making sense. Because section is a very useful command to have. The only curve I want of these is this curve here. Going to do an offset from these. I want the under bezel to be maybe somewhere in that area. Like I said, usually about 1/3 of the way down. I can actually draw the girdle in. Do the same thing over here. Actually draw the girdle here so I can see it also. So this is treating it like a drawing instead of a model, which is perfectly valid. That's where the corner of the upper girdle is. Okay. All right. So I can do a couple things now. If I just do a regular fillet with a radius of 0, I can see where those meet. That's not giving me very much room for metal on that stone, center stone. I don't want this, Teddy, when I do this, I don't want to have that metal come any closer than like 0.4. So that's about as close as I want that corner to come to the inside of the stone there.
So you want like have enough space for like the prongs to fit together?
Well, enough space for there to be metal between this stone and that stone.
Right.
Yeah. So something like that is going to work. So to know what that looks like, I filleted that. And then I can offset this. That's a pretty high under bezel. It's not terrible. It's a little too high. So I'll compromise. There. Don't want to move, I want to fill it. There and there. So that's where my under bezels are going to sit. I'm going to mirror this one over so I have it. Don't need that anymore. Don't need that anymore. Don't need any of the points that are there. I would like these curves to come out far enough to reach beyond these stones. I have several ways I can do that. I'll use a scale. That'll do. Something like that. Now I have found again and again and again, Teddy, that having this hard corner causes me trouble. So instead of having a hard corner between those, I'm going to round the corner. When I round a corner, I usually do it by bringing in a circle. And then using that circle to trim. The corner away, and then using a curve blend tool, adjustable curve blend, to fill the gap. Just because it's easier to work with something soft here. It's still a corner, but it's not a hard corner. And that's easier to work with in metal, and it's easier to work with in CAD. Does that make sense?
Yes.
I'm going to extrude this out now so that it encompasses your stones. So it's big enough to cover them. Both sides. Like that. But I don't really have a girdle for this one. I'm going to get one quick. I'm going to take off the top of it, join it together, duplicate an edge, copy that out of Rhino, undo, 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 and paste it back in. This will come pretty much straight down onto that surface. So I can do that with a project. I don't want to delete the original, so I keep that delete input equals no. I want a color I can see well, so I'll do it in white. There's that curve.
So why is it like, kind of like,
Going over the
curvy?
corner?
Yeah.
Because that's because where that curve takes place is inside of the girdle.
Oh,
So if in order for it to not do that, we would have had to keep this coming straight all the way out before it rolled. And if it did that, it would have ran into the side stone.
oh, I see.
So these two stones are going to share this same plate of metal. Now, I don't want this to be quite that big, Teddy. So I'm going to project it to the C-plane so I can work with it flat. And I'm going to do an offset. Just a little bit. 0.2 is enough. And I'm going to bring it back up with a project. Project to surface is just the reverse of project to C-plane. So I like that. I can see where that's going to work. I'm going to grab this. Got to ungroup it. Steal that. I want to bring this curve straight down onto this surface. I have a couple of choices as how to do that. I could extrude it and do an intersection, but I like projecting. So I'm going to set a C-plane to the top of that stone. That didn't work. There. I can tell because the grid will line right up with the top. And then I'll grab this and I will project the C-plane. Actually, no. I'll project on surface. Sorry. And that throws that straight down. Let me show you the other way I was going to do it because that may be less confusing. Extrude. Intersect. And then throw that away. Gets you the same thing. They both work. Now, once again, if I wanted that to be thinner, I would offset it before I did it. But I think that's going to be fine. Mirror it over. And now I'm going to turn my stones off again. And take a look at what I have. So that's going to be basically my plate. These three shapes. I want to do something nice. I may want to get a little more creative than just these three shapes. So I'm going to select those curves and I'm going to project them to the C-plane again. So now they're gone. They're all down on the ground. But the reason I did that is so that I can draw with them a little more carefully. It's easier to work flat. The thing I didn't love is I don't love this corner coming deep like that. Now a prong is probably going to fill it anyway, honestly. But I have a couple of choices I can do here that I would try. One, I could just do a straight line that comes over like that and just kind of fills in that gap right there and does it in a very geometric way. Another way to do it would be with a curve. Grab a circle, mirror it all around. Use those circles to trim. And then blend curve, adjustable blend curve. And do something like that. That would also be fine. I actually think I prefer the straight line, to be honest with you. So I'll go back to that. Just going to draw a straight line. Come in here, something like that. and use that straight line to trim. That inside corner away. That sharp corner, you may wonder why I'm taking it away. It's not that it's ugly, it's that something that's that severe and tight, it's going to be really hard for manufacturing. There's no way to get a file in there, there's no way to clean in there. We're going to be putting prongs probably in here anyway, so we're probably going to fill the whole thing with metal behind the prongs. So having this sliver that ends up being a hole eventually that you got to deal with just didn't make sense. So I just made it a little simpler by removing that hard corner. It is a maquette, so it doesn't matter that much. When I filled it, it trimmed it from the other side. Put it back. Drag a window. Join. Now I have this, I can bring back the surface and project them right back where they came from. Trim. Look at the stones. See, you can see where that straight edge leaves a little bit of visibility there. But the prongs will cover that up, and it just makes a little easier piece to work with. The next stage is to extrude that down to a point so we can fill in the taper of the thing. Taper to a point, we need a helper curve, just something we can grab straight up and down. Grab that curve and extrude to a point. Use near snap and grab onto that curve. And you can slide up and down until the angle from here to here looks like something you like. Maybe something like that. And I can extrude this straight out. And use it to Boolean difference. Oh, I know why. Boolean hates it when one thing is open, has a hole in it, and the other was closed, and I hadn't joined the lid back on to that. That's why it acted up. Going to take a look at your shank. This should be offset 2 millimeters. That's the standard. And then we usually move it up like 0.35 to make it a little thinner at the bottom and a little wider at the top. Extrude that out for your shank. And I do it 1 millimeter each side for a total of 2. It's a pretty standard. And you've already got pretty much the makings of a maquette. Only thing we have to do now is cut a window in here.
Do you also have to like take out, like with the like how you just made the ring? Do you also have to like take out the metal inside it as well?
Yeah, I would take the metal out. The inside of the metal of the yellow box, the orange box, needs to be cut. And then the shank, for a finished model, would be cut. But for a maquette, we don't care, because we're just using it to get lines to draw on top of.
Oh.
But they're both easy to do. If I wanted to clean the shank out of there, that's easy to do as well. Are you thinking, I'm going to actually steal the curves from this. I already have them. Our time is up, but I want to go a little bit further with you. Can I get a section of this again? Section command is really useful because it gives you a nice two-dimensional drawing curve to work with. Do you think you're going to have your shank come in straight, higher, or curved up in?
Yeah, like curve.
Curved. Okay. If you're going to curve it up in, the easiest way to do that is to draw a curve across here to decide where it's going to start to curve backwards. Reverse its curve. And I would say about there. I'm going to grab that and I'm going to split it. Before I do that, I'm going to check where the seam on this curve is. I'll bet it's right here, and we don't want that. For rings, we always want the seam at the top or the bottom. In this case, the top, because we're going to cut the top out. Curve. Edit tools. Close. There it is. Told you. I knew right where it was. Move it from that quad to that quad. That way, when I split this, that seam is no longer part of my shank. And then curve, extend by arc to point is one way we could do this. That gives a fairly soft curve. If I wanted a more assertive curve, I could draw a straight line down and then do a blend curve. And then I could play with these handles to get what I wanted. If I wanted to feel like it was coming right up to here, that'd be a bad idea. Because you have to remember, in three-dimensional space, it's not really a corner, it's an oval. And if the shank comes right to the edge of that oval, you're going to have weird things to deal with. You're going to have an extra shank left over hanging out on the sides of your oval. So you do want it to tuck in. This is just a maquette once again, it's not a finished model. But I think that should be all right. Mirror that over. And I'm going to do a blend curve again between these two. Shift key to pull it down. Join them together. It looks funny, but we don't care because I'm going to cut the part we don't use will be cut away anyway. And I'll do an extrusion again for that shank. I want the ring more too. Okay. Looks a little crazy, I know. But it is fine. Because now we're going to cut out pieces we're not using. We want this to be usually about 1.2 millimeters, so we'll offset it that far. We want this to be offset usually a millimeter, 9/10 to a millimeter. So we'll offset it to 0.95. Usually I scale that a little bit from the center. So there's a little bit of a taper in here. And all that matters to me, Teddy, is that the line that connects these is outside of my orange box. Because if it's not outside the orange box, it won't cut it. And I need it to cut. I'm going to cut a window. Other than that, I don't really care where it goes. So I make sure it falls outside of there. And I fill it. That corner, mirror it over. Fill it the other side. Grab both these curves, trim out the middle. So I have that. Fill it again. Join all this together. And I have my window. Just like that. We're going to create the real window by extruding it out again. tap it, and then doing a Boolean difference. Before I do a Boolean difference, I'm going to copy. Remember this. This is how you got in trouble before with your Boolean. Grab these things, Control Copy, Control Paste, Control Group, Control S, Control G, and I'm going to put it on a storage layer, storage objects. Turn that layer off, and now I'll do my Boolean difference. And then to make this make more sense, because it's a little bit crazy, I'm going to come inside of here, and I know I need to have the shank overlap a little bit or it won't hold on. You have to have metal or nothing holds together, so give it a little bit. That's fine. That's probably too much, actually. Take it to the other side. And I just want to make a cutter, so I'm going to do my blend curves again. And I will extrude out. Extrudes are what you make a lot of maquettes with. Most of maquettes work is just made from extrusions. I'm going to do another Boolean, so I'm going to Control, Paste, Group, put it in storage, and then solid difference. That piece I no longer need. I have a little weird corner sticking up. Now I could just leave it. It's a maquette, nobody cares. But if I want to cut it off, that's pretty easy to do. I'll just extrude this surface straight out and move it down a little bit. I want to Boolean this corner off, so the direction of a single surface. Teddy, when you Boolean, you either have to use a solid or a surface or a poly surface. If it's a solid, Rhino can figure out what to do. But if it's not a solid, Rhino doesn't know what is inside and what is outside, which means it doesn't know how to cut with the three-dimensional object. So, if you have to tell Rhino which direction you think outside is, because it's the outside of the tool that cuts. So we want to make sure that the surface points towards whatever you want to keep. So, analyze direction, arrows will pop up. And see, those arrows are pointing towards what I want to keep. If they didn't, let's say I did it that way, and I did solid difference, Boolean difference, all I would keep are those little points. And that is not what I want, Teddy. So, I make sure that the direction of this is pointing the right way. You only have to do that with a poly surface or a surface. If it's a closed surface, if it's a solid, you don't have to worry about it. Rhino knows what's inside and what's outside. But as long as an object has a hole in it, Rhino can't tell. Might be the inside, might be the outside. With the lid on this bottle, it knows what's inside, what's outside. Once I take the lid off, to Rhino, this could be the outside. Inside, what we call inside could be the outside, because there's a hole in it. Rhino doesn't understand holes. So that's why if you're using something that's not closed, using something that isn't a solid, you have to check and see what direction it's pointing. So which direction is out? And that direction that's out is the arrows. So analyze direction. Those arrows are pointing the right way this time. Solid difference. Grab these pieces. I don't want the curves. I just want the blocks. Control C, Control V, Control G. Copy, paste, group, put them in storage. Solid union. That's a maquette. Bring your stones back. And now that you've got that, like I said in class, I keep everything. So all of these curves, I'm going to grab a window around them, I'm going to group them, and I'm going to put them in my storage curves. Makes a much cleaner file that way. If I ever needed to get like those objects back, this looks like a mess. But because I grouped everything, Teddy, if I click, I can see exactly what that is. Click, I can see exactly what that is. And because they're grouped together, I know, oh, those are those two pieces. Oh, that's these two pieces. That's why you want to group them. And that's it, Teddy. We're out of time. You will have to figure out to do the drawing part on your own. But that shouldn't be hard to do. Do remember that when you make a drawing, you're going to want to Boolean the stones in. Because Rhino won't draw the stones right if you don't Boolean them into the mounting.
Okay.
But when you do Boolean the stones in, you're going to take the stones, the mounting, Control C, Control V, Control G to group it. And then you can either put it in storage, or what I would do is hide it, because I'm going to take it right back in just a minute.
So I can just like put it in another layer as well, too?
Yep, just somewhere where it's safe.
Okay.
And now I can do the union. And now Rhino will make a drawing of that with no problem. After my drawing is all done, if I want to keep it, I can keep it. If I don't, I can throw it away and bring back the pieces that weren't Booleaned. And that way I'm safe.
Thank you.
You bet. I'll save this for you. I'll save the video.
For like, would it be fine if like share this to me and like on the side for like the toolbars? Would it be fine like you could do like a note for like what thing I should do next?
You'd have to follow the video because I don't have time to go through and do that.
Okay.
Yeah, this is all the time I have.
So this is so just follow the drawing video?
Yep, you follow the. I'm sending you the video of this office hour. Everything I've talked about has been recorded. This whole process is a movie. So you take this office hour home with you, and you can watch it as many times as you want.
Okay.
And you have the file. I will send you the file.
Thank you.
So you'll have the file and the video. You should be able to figure it out.
Okay.
All right? And then the other videos from school, from class that you can watch to figure out how to do the drawing and stuff.
Okay.
All right?
Thank you for helping.